on slope failure topics. Okay, the slide will be concentrate on, okay, just to give initial content of the chapter 3. So this is our main reference textbook. You can download or have this textbook from the pdf.com website. So you just type any textbook title, you can have a copy of PDF. So what's the important about this textbook is actually a complete explanations on the case history or case selected presented in your lecture note. So if you go details from the beginning to the end, some sort of these notes are quite, what we call it, they just take it the important point to be highlighted in the slide. So if you feel that you are not very clear about what these notes mentions, go to this textbook, and then it's very easy and clear all about the cases stated here. And what are our learning outcomes? What do we expect from every one of you is you are able to investigate and analyze geotechnical failures. So if I am not mistaken, during the early semester, you have been given the introductions on forensic engineering, and then on the structural failures such as building, bridge, and then that are the chapters 1 and chapter 2. So right now, we are trying to analyze and investigate geotechnical failures such as settlements, bearing capacity failure, excavation failure, and then lastly is a slope failure. So it's actually many failures can be involved during the geotechnical construction work. So we only focus and limited to these 4 types of failures. So if you encounter any types of failures that related to geotechnical engineering, you can also put in your activity work. So there is no problem. Okay, the next learning outcomes, number 2 is able to formulate likely scenario for technical failure and develop rectification measures. So as you can see, we try to map the CO1 to PO2, which is analyze and investigate, and also PO5. What is a PO5? In OBE, in our program, EAC, PO5 is what? What is PO5? Is it a tool? Kelas, you all dapat 7 kan? PO5 dalam EAC apa dia? Muhammad Rizwan? Muhammad Rizwan. Hilang dah guide. Okay, nampaknya you all semua ni hadir secara temporary. Kelas PO5 apa dia?
Design solution.
Pandai. Saja je nak tengok you all ni. Sebab kan mungkinlah kita dah lepas EAC yang besar baru-baru ni bulan 10 Tapi sebagai yelah you nak keluar nanti kan future graduate engineer kan. Kalau kata sebab kita ni mungkin berhadapan dengan future boss kita orang IEM contohnya. Engineer, kita tak boleh memilih kan siapa bos kita. Dia yang boleh pilih pekerja. So kita tak boleh pilih bos. So kalau dia tanya awak dan dia tu pula adalah member of IEM, BEM. So dia akan tanya you, do you aware about the EAC, and then what is the OBE, what's your program outcome, PO, etc. And then how many PO do we have? What is a PO5? Can you answer it? Sebab kadang tu dia tak nak tanya pun pasal your punya courses, your knowledge kan. bila cerita pasal civil engineering, dia banyak. So dia takkan fokus kepada what you have achieved, obtained throughout 4 years degree program. Dia akan tanyalah luas sikit daripada topik kan. Contoh macam forensic engineering ni. More likely our what we call it, our general knowledge on some cases, failures. Adakah kita membaca newspaper? Adakah kita hanya melayan TikTok? Or we only read magazine yang not giving you any some developing critical thinking. That's are the things yang when you are preparing yourself to be in the market, job market, you have to make sure that yourself is full readiness. So it's not that 1 minggu sebelum interview barulah you nak select belek newspaper, barulah you nak baca-baca, sebab kita tak nak nanti bila bos dapat calon kemudian the return feedback or this graduate daripada UiTM calon Kepala Pinang not good. Kita pun tak tahu apa yang tak bagusnya kan. Dia hanya menilai during the interview session. So it's not represent the whole pictures of the civil engineering faculty itself. So it's only represented by yourself. It's not fair to say that the program at civil engineering in Penang is not good. So make sure that you are preparing yourself in full aspects from general knowledge and also from the engineering knowledge. So kalau kata general knowledge ni macam tadilah, cases yang terlibat ataupun apa yang news yang you ada baca, terdengar kan, sama ada new cabinet. Currently kita tengah hot pasal apa? Sekarang news tengah hot pasal apa? Dalam sport. Apa sekarang orang sibuk-sibuk?
World Cup.
World Cup. Because World Cup is something that everyone, not in Malaysia, not in civil engineering students saja yang apa kata ambitious or curious to know who's going to be what team will be at the final match kan. Itulah yang something that kita kena sentiasa bersedia lah from all aspects. It's not under our disiplin saja. Knowledge disiplin, kita kena tahu juga the trending now. Baru-baru ni kita baru dapat new PM kan, and then kita kena tahu siapa kabinet dia, apa functions dia, menteri-menteri ni apa tujuan. Kenapa saya cerita panjang-panjang lebar? Sebab you dapat 7. Dah kategori senior, bukan kategori junior. Kalau kata dari segi open-minded to answer, to ask, dia bukan lagi macam budak year 1, year 2. You already matched in terms of the all aspect lah, attitude, your knowledge, and then your preparation, your readiness. These are the things that I like to focus selain daripada subject matter. Okay, back to our topic today. Okay, in this part, as I said, we are having 4 types of failures. Never mind, from type 1 failure, from type 2 failures, I have been given in the YouTube lectures. So I hope that you can have your personal view watch from the recorded video that will be counted as a class replacement during the public holiday announced by new PM last weeks. So I hope that will be fine and you allow me to do that. So now we go to the slope failure. The slope failure, before we can go to some specific cases, I just like to remind every one of you, because in forensic engineering, aside you are knowing about the cases, the case description, for example, when was the case happen, what time, what are the impact to the environment, is it having some sort of the life loss or structure damage, and then is it involved with the community's awareness? So these are things, general informations on the case descriptions. The most important is you are able to understand the theory, analysis, design behind the failure itself, because we want to investigate from the beginning what are the causes, and then how can we deal with the geotechnical aspect, and then how are you going to explain in a simple way but involved with the technical explanation. Because when we have some case failure, the public authority will hire certain private or group of the engineer to invest, to come to the site, investigate the causes, the effect, and then what are the best solution that can be taken by public authorities, so that in future we can minimize the failure or minimize any losing. So, and the important part on the technical knowledge is understand what is the theory behind the failure itself. I mean that you can identify the slope, the slope failure category, and then in terms of the strength, stability, in terms of the failure mechanism, what are the calculations involved, what are theoretical involved behind it, how do you calculate the factor of safety. So it come back to the topic in soil mechanics, come back to the topic in the geotechnics. So the simplest way to explain to you, we have two categories of the slope. The first one, we call it as a natural slope, and then the second one, we call it as a man-made slope. Most of the cases, the slope failure can happen due to the man-made slope, because originally we understand that if there is no human activities on top of the slope, on top of the hill, there will be no chances of prone any failure can occur. That's very simple understanding. But then when you are planning to have future construction on top of the hill slope, there will be chances of potential slope failure can occur. So you have to take any future remedial to prevent any kind of the future failures that we might not expect due to the environmental climate change or etc. So these are the things that I think that the first of all, understand what is the definitions, and then understand what is the types of slope. So when you go to the site of the case failure, you easily can identify, okay, this slope is failed in this two failure, for example. The slope failed due to the base failure, or the slope failed due to the circular failure. So what are the differences? All these three types of slope failures, I think that you can go back to your geotechnic textbook to read or to find out what are the differences. But the simplest way to understand, if you go to any area, you look around surrounding you, you can say, oh, this kind of slope is man-made, this kind of slope is a natural. Is it any potential slope failure happen in the future? And then how do you figure out, or you visualize the mitigation, the remedial work has been carried out by this contractor to prevent any failure. So you taking all your informations, your knowledge and the technical aspect to do some this activity, to do on this part of investigations. Okay, this is our example cases also that coming together with the debris flow. So you can see that the soil being carried out by this water. So it's not only as a slope failure, it can be categorized as a debris flow and also the landslide. So landslide, debris flows are different also to the any simple slope failure. And other than that, you can see that the failure also can be happen naturally. And for example, in Bukit Lanjan, but the Bukit Lanjan in KL also happened due to the uh, firstly occurred, it's being constructed for highway, and then due to the rainy season, water infiltrate that make it the weak the rock structures between it having a weakness, so the water infiltrate to the weakness plane and causing to the rock block fall. So these are some examples of the natural slope failure. So as I said again, rockfall always can occur at the side of highway, and this is Bukit Lanjan just I mentioned now. So you can see quite massive rock falls on the road surface, and what do you expect is that we have to close this road from these two directions. And then what are the causes? You can see the simplest or the slope analysis cannot being carried out as what we analyze for slope, for soil slope. So you can take as a one block or using the wedge analysis to identify or to determine the factor of safety during the failure or the future post constructions to determine the best mitigation design to prevent any failure. Okay, this is another things happen in KL also, Kampung Pasir, Hulu Kelang, which involve 4 lives. And then you can see that this is all about human activities where you on top of this slope, on top of this soil surface, there were houses built on this the slope or the hill. So you can see it is not even the soil color is represent having a high strength, but when water come in, the external forces can give the soil here in stable conditions. So you can see some buildings already collapsed, and then there's some kind of debris flow. So these are the results from the slope failures. Okay, I think that most of you has heard on the slope failure at Bukit Antarabangsa, or if you do not know about this news, you can find out. So now it's become a haunted building, and then nobody live in this area in Bukit Antarabangsa. Bukit Antarabangsa last time ago was a very residential elite area. So people who rich were living here, and then due to the case in 1999, and all residents moved out from this building and left the building empty and become haunted. So I am not sure how haunted it was, but you can search from YouTube. And then the post debunk, so you can see that this is a debris flow. Okay, features of slope failure I will not explain in details, but just showing to you how the process involved with the weathering effect, and then from the intact rock being weathered by dry and rainy season, forming to the weak soil on top of it. And then the slope materials will be differ according to the deposit. Either you have the alluvial deposits, glacial deposits, Elenian deposits. So these all involved with our geological features. Our parent rock, is it we have a sedimentary rock, granite rock, or metamorphic rock? So the alluvial deposits is mostly transported by running water and deposited where the speed of the water flow can no longer sufficient to carry them. So all this kind of deposit explain to you when you have some kind of debris flow. And these are other things of the material. Okay, just give it to you the simple on the slope stability analysis. As I said earlier, when you are dealing with the forensic engineering, aside you know the case descriptions, and then you know what are causes. For example, you went to the site, you go to the site, and then you found that any small water channel or water flow. So you can say that the slope failure occurred due to the water presence. And then how do you support your justifications? You need to take a sample and bring to the lab. All the physical and lab testing being carried out to determine what are the index properties, what are the soil strength. So then in the future work or mitigation work, we can do some sort of analysis using the manual calculations on the slope stability, or you also can use a numerical software to analyze the factor of safety. So on this part, for mitigations, by using the numerical software, we can have a post analysis or we can have the back analysis. The back analysis, we can determine what was the strength during the failure, and then what is the best source strength to prevent future failure. So these are the reasons when you are dealing with the forensic engineering. It's not that you go site, then you find out what are causes, effects, and then you go back. No, and the work is not finished there. You need to carry out by conduct some testing on the soil, determine the index properties, determine the grain particle size distributions, and then do some sort of the triaxial test, for example, and then some kind of what other things, compactions. So this will be support your analysis to mitigate what are the best technique to prevent anything future failure. For example, here today I'm talking about the slope failure. So you will be proposing either using the soil nailing is a good thing, or you can propose using the soil nailing plus membrane, or you can propose the mitigation for slope protections using vegetations or using the berm. Which are the best techniques of mitigation that can have in future that can be taken by our public authority? When you go to the public authority or to your client, there are many things will be involved, such as are you following to the guidelines? Are you following to the standards? Are you proposing the mitigation work that in our budget constraint? So all these factors are being considered during the decision making. So what I'm trying to say is that without having a full understanding, theoretical analysis, and also some general knowledge on part of the construction, etc., they will be not help you to propose the best solutions to the clients. So you have to be what we call it. That's why I said you have to be a good one in the full package that able to deliver the information, to do some sort of the decision making, to do the analysis, and most partly having a critical thinking. The part of critical thinking carrying on the analysis itself, for example lah. Okay, on the slope stability concept, I hope that every one of you familiar how do we do the analysis. You can take simple analysis assumptions from Tezeki, for example, and then if you want to analyze using B-sharp technique for long-term stability or short-term stability in the total stress or in the effective stress. If you are considering the failure for long-term stability, what will be the stress parameters need to get in calculation? Either we are using in total stress or we are using in the effective stress parameters. So all are being answered through our lab testing or also from the site observation and site explorations. If you have more money, you can do on standard penetration test. So first of all, what do you need to do? By looking at the friction concept here, we have normal forces, or we call here as the effective stress, and we have also weight of the block, and we have the shear resistance or shear force, and we also having the pulling force. And the resistance force is equal to the nu n. Nu is the coefficients to the relationship between normal or effective stress with the F. So in soil mechanics, the nu is equal to the tangent phi, and is a sigma effective, meaning it is carrying out by using the shear stress equation or Coulomb equation. The shear stress is equal to the effective stress tangent effective phi. If you split it, the slip mass circle above the slip circle here into few vertical slices, you can analyze it using manual calculations, finding what is the disturbing moment and calculate the resistant moment so that you can have the factor of safety. But it takes time to do all this analysis because we have to divide our slit mass into few vertical slices and doing the calculation. But then with advanced technology, we can adopt the same technique from the theoretical into the numerical software by limit equilibrium method. So the limit equilibrium method will tell you the most critical slip circle at the most locations at the center point of the slip circle. So at the center point of the slip circle that will produce to you the most critical that can give the value of the factor of safety. Remember, what is the factor of safety if we consider the slope is stable? Anyone would like to answer? What is the value FOS if we say that the slope is stable?
2.
Berapa nilai?
1.5.
Berapa?
1.5.
Itu pakai standard mana? Alah, senang macam ni. Kalau manual calculation kan, kalau you dapat FOS je equal to 1 tu, kita dah kira stable lah. Tapi kalau you go in detail, because we are doing the forensic, right? When we want to design for mitigation, of course, we have to comply with the guidelines, public authority, etc. Some guidelines or JKR or any public authority might say that okay, for this kind of the slope with the parent material igneous, for example, sedimentary. So it is suggest to have the FOS 1.5, for example. So if you do the manual or computer calculations analysis, you have that 1.5, it's okay. But then if you go or you have less than 1.5, you have to redesign your slope. Redesign slope meaning that you can change the slope angle, you can change the slope height, and then you can change the slope all in slope geometry, meaning that, or you can increase the berm, or you can have a single berm or many berms, or you can propose having some anchoring techniques by soil nailing or soil anchor. So these are the things that can be involved during the mitigations stages of calculation analysis. Okay, it's okay. Thank you for the answer. So again, in range 1.0 to 1.5 can be accepted. Okay, this is when you involve with effective stress concept in slope stability, but somehow the simple analysis being proposed here is not suitable for kind of in Malaysia, because have you heard on unsaturated soil? Unsaturated soil is condition where we have some regions in a dry zone, and we have the wet zone, and suddenly there's some encounter water effect, water pressure. So you cannot anymore calculate effective stress without considering the suction or the suction effect. So on part of unsaturated soil here, you can see that the shear stress has been elaborated more, included with the suction effect, where you have the air pore water pressure minus dengan water pore pressure. So last time we only considered the pore water pressure only. We not considered the air pore pressure. So now in unsaturated soil, the formula is extended by considering the suction effect having the UA minus with the UW. So this quite advanced soil model explained to you when you are dealing this kind of the slope failure. It is not anymore recommended to use a simple shear stress equations. So it is proposed to you to analyze it using the extended advanced shear stress equation such as here. Yang ni so makna kata if you want to analyze using manual calculations or you use any numerical software, most of the numerical software will adopt the advanced technique. So you can choose either you want to analyze the slope failure in limit equilibrium method or finite element method by what methods or theory on part of to calculate the shear stress. So I will not touch further in this theoretical for unsaturated soil. So this is what I said. Modes of slope failure, we have base failure, shallow or face failure. We also have the translational slides or rotational slides. So these are the factors affecting slope stability. So in a way, for you to describe the case failure, you can take, for example, any available factors such as erosions, the pore pressure increase, and the presence of the tension crack, mostly in the clay or in the soft soil, and then the change of stress condition and the rise of the groundwater table, rock mass discontinuities if you involve with the rock fall. Also, these are factors that can be considered that might affect to your factor of safety calculation. So when we talk about this one, it is involved with the soil strength or the rock strength. Okay, the main items required to evaluate the stability of the slope. So we need to know the informations on the shear strength of the soil. What are the shear strength of the soil, class? So when I say shear strength of soil, what exactly the parameters? Apa parameter dia? Nur Syaira. Nur Syaira Tasnim. What are the shear strength parameters? Kita ada ke Nur Syaira ni? Kan Amira nak jawab. Kita ada dua Amira. Amira apa ni? Amira Sanim. Apa parameter dia?
Dia dekat dalam moska kan. Yang tahu.
Ya, betul-betul apa dia?
Yang tahu.
Delta.
Tahu.
Okay, tau. Tau is a shear stress. So what are parameters give effect to the tau shear stress? Apa dia soil strength parameters?
Based on the cohesion.
Normal size.
True? Cohesion? And also?
Dengan dia punya fee.
Yes, friction angle. That's our correct answers. So the most part when we do the analysis, either you are conducting for the back analysis or the current analysis, we are very concerned on these two parameters. But the first one you have to look at on the soil type. Either you are dealing with the clay, or we call it the fine soil, or you deal with the coarse soil, which is sand. So if you are dealing with the sand, for example, we can say that the C is equal to 0. Let me taking as a dry sand. If you are dealing with the purely clay, we can see that the phi, the internal friction angle, is a 0. So these are the things when you go back to this notes. That's why it says that it is written here. The first one is the shear strength of soils. Very important. The items required in your analysis. And then the slope geometry, as I said just now, the slope geometry can be focusing on the angle of the slope. Either you have 10 degrees, 20 degrees, 30 degrees, and then 45 degrees. And the next one is the pore pressure or the seepage forces. As we know that the effect of the water causing to the additional loads on the slope itself. Just imagine if we have a dry soil and then we have a saturated soil. Which one is more heavier instead of the volume? We're looking at the volume, we can see that the saturated soil more heavier compared to the dry sand, because there is additional forces from the water itself, water pressure. And the next one is the loading and environmental conditions. Loading, for example, as I said just now, I showed you one case on the slope where we have a buildings or houses near to the hill slope. You can see that the structures contributed to the stability of the soil itself, because it gave some additional extra loading that the soil need carry out. So imagine if the soil can be taken only 10 kilonewton, how if you increase to 20 or 50 kilonewton? So from that, you can do some sort of analysis, try and error. If you add 10 kilonewton, is it the FOS is 1? If you increase more, is it achievable FOS still 1 or less than 1? So from that, you can say that our design limit for load is only blah, 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 blah. Why? If the client asks you why we cannot go more than that, you can say through our analysis, this is what we found out. We have do some analysis on this kind of the increasing loading. We can see the results, the output is that can cause to the slope failure where FOS less than 1. That's how you justify your design when you need to produce a report. So I am not sure for your project, is it you have to extend the report to that aspect by having a numerical analysis and then put it together, lab data, and also the soil exploration input to support your mitigation analysis and mitigation techniques. So if you can have that things in your report, that will be more goods lah. I mean that you can produce more marks lah. Remember, if you can have comprehensive reports, it tells you the whole aspects of the failures and how do you carry out the process of investigation and also identification, and to the last one, analysis and design. So these are the good things about if you can more in that. Okay, that is I said suction. So in advanced theory, the column theory is not anymore support the slope failure. So we have to include also the formula by having a suction effect for pressure, air pour, and also water for pressure. Okay, this is more advanced, so I will not go in details. Okay, it's actually about the failure due to the infiltrations. So what and how when we can do the analysis using the limit equilibrium analysis, or you can use the finite element analysis. Okay, this is when you want to explain the relationship, the stress and strain between the soil properties and soil criteria. And then the failures itself, the more column failure. Okay, all that one. Okay, we go next to the second notes on this slope failure. So I'm not telling all important aspects because some have been touched just now. So let me start from here. Let's say the suction from previous note, and then why landslide can occur. There are few reasons. So this talk given by practitioner engineers from the GU company, GU Geotechnical Company. So if you are looking a good geotechnical company in Malaysia, I can suggest you submit your CV and resume to this company. GU Geotechnical Company is very distinguished company in Malaysia where they involve with the geotechnical works and also consultants. And the cause of landslide, for example, design errors and then constructions, design and construction, geological features, which cannot be avoided, the maintenance. So they found out that the number of cases that they were involved, 49 cases. So the most contribute cases coming from the design errors. So you see that the design errors number of cases are 29, and the percentage failure is 60%, followed by design and construction errors. So who did the errors? Siapa yang buat salah ni? Who did the errors?
Design.
Designer.
Yes, design engineer or geotechnical engineer. I am not sure what were causes or cases involved in their study here. I mean that how they get the data and the design errors are mentioned by the numbers. So most contributed due to the human error at the initial stage of the design and analysis. But I think that during the time when the engineer designed for the initially, by having some sort of information from the site or from the existing data, at the time they design, maybe the properties, all those criteria are safe. Due to the some period of time, some additional effect, environment, geological features, the failure can occur. So quite biased statement. I am not sure because I don't have the full information. So we can make conclusions that due to the design errors, contribute 29 cases out of 49. So be careful when you get involved with the design and construction stage. Okay, they also elaborate more design and constructions errors. For example, is a prescriptive method, insufficient site investigation and laboratory tests, and lack of understanding of soil mechanics. See how important to every one of you to understand what is a drain analysis, effective stress, and also the total stress. Okay, this is example how it says that if you have a design geometry 1-to-1, one stand to the one vertical to one horizontal, is it give you safe cut slopes or unsafe cut slope? So looking to the information here, landslide on the cut slope which measured about 16 meter high, quite high lah kan, about 1-to-1 tu macam tak stabil lah. Kalau kita tengok pun kita nampak dia tak stabil kan. Other than that, soil properties from the site investigation and also from the lab. So you can see from here, let's say we have two cases, two slopes from slope 1 and slope 2 having the same soil properties. Effective C1 and then phi is 38. The second slope 2 is 28 degree. So we can see that the first slope 1 is more stable compared with FOS for slope number 2 less than 1, which is 0.9. So why? If you see from here, the geometry of the slope is similar, 1 vertical to 1.25 horizontal. Similarly for the slope number 2. But the reason is having a different soil properties. The first one having more high strength, which is 38 degree, whereby slope number 2 only has 28 in strength, 28 degree. So of course, we can say that slope number 2 instable compared with slope number 1 due to the reason of soil parameters. And it is recommended for engineer to follow this manual. For example, if you're having some kinds of economic risk, negligible, low, high, or what's etc. So you can see, for example, we can have more than one negligible for the 10-year return period rainfall. And also you can see that if you go to higher, it is recommended as a 1.4. Just now what Hani mentioned, Shahira Hani mentioned was true lah, because we adopt around 1.0 to 1.5 or 1.4. So it will be a different value proposed by any other public authority. For example, here this one given from Hong Kong by the government of the Hong Kong. Okay, this is also similar to the effect of soil properties. The relationship effective C versus the percentage of fineness. And if you're looking at the left and right sides of the slope geometry, the left side we don't have any berm high, we only one slope angle. And then the right side figure indicates to you we have almost three berms height with let's say we have the angle, each berm is similar, but the number of berms are 3. It says that if you have one slope angle, is more safer compared to you have many berm. In terms of the slope protections, it is may not suggested to have or to increase the soil strength by having the berms. Looking to the soil properties, these two slopes have carried the same soil properties. For example, effective C is 1 and the effective friction angle is 33 degrees. So the causes of the failure is due to the berm number. And also the slope angle 45 degrees is not safe. It says also the slope unstable when you propose increased number of the berm. So at the last here, you can see how many berms we have. 1, 2, 3, 4, 5. Five number of slope with FOS 0.959 is not safe. So you have to back to the one angle only. Okay, similar to here, and then the groundwater table effect. This is what I said. If you have some sort of suction, unsaturated soil, some zone, upper zone is a dry condition, and then below the groundwater level is a saturated conditions. So this is where the water infiltrate between two zones in dry conditions and in the wet conditions. So the simple Moore column is not more applicable to analyze this kind of the slope stability. The higher groundwater level, the lower the FOS. Okay, this is also suggested to you if you construct slope protection using the rubber wall. So what is the best height recommendation and the width of the embankment? Also, this one, you can see that the width of embankment remain the same and the dimensions of the wall will be changed accordingly to the depth of the soil. So you can see that by proposing at which depth of the soil that can produce to you safe construction design. Okay, this is the remedial work using the soil nail. Okay, this is how it is involved when you are proposing for future remedial or mitigation work. So these are the things you have to consider. First of all is policies and legislation, and then slope maintenance, structures and anything that relevant to it. If you are dealing with the engineering aspect, we have to concentrate on the policies and legislation, slope maintenance, constructions, quality control, and site supervision. Most of the time, when we design in the period of 10 years, for example, and the next 10 years, who's going to monitor the slope itself in terms of the slope protection technique, in terms of design itself. So that's some reasons failures can occur due to the weak maintenance work. Okay, policies and legislations. These are the parties involved: DOE, JMG, MPA, JPBD, IEM, ICRAM. So you have to find out any guidelines from all these parties, body of organizations. Are they or your design fulfilling their requirement? So these are some suggestions if you are dealing with the class 1, class 2, class 3, class 4. So each class indicate to you the criteria of the slope or the aspect. For example, if you have the class 1, the geotechnical limitation is low, suitability for development is high, so engineering cost for development is low, intensity of site investigation is normal. How about the train? The in-situ train is recommended less than 50 degree. Cut platform in-situ terrain. Maknanya they can suggest you by looking at this cut line, you know that what is the best work can be carried out on the site. This is how ICRAMs propose their requirement, guideline and characteristic. IEM itself, and then come up with the proper design. And these are the policies and legislations involved. So all those aspects are very important. And what are the things? Next is a construction control. So the construction control, because in the early we found that almost 60% of the failures due to the design and construction errors. So we can do the precaution work before we start the construction activities, such as site personnel with sufficient knowledge and experience, close coordination and communication with design engineers, maintain detailed site records. So the site records can be obtained through the site exploration or from the public authority or from any neighboring area to our construction zone. So what are construction controls? The first one, you need to from the process here, let's say applies for temporary and permanent works, and then do some legal provisions as work specifications, and then do some BOQ item for temporary slope and protection works, and then next contractor to be penalized for non-compliance. So the last thing here, the last process is very common if you cannot comply within the period of the construction durations. So they will terminate you according to your work progress. If you not meet to the work progress, you are required to quit or stop from doing any construction activities. So in conclusion, so streamline and harmonize existing policies and legislation. As you undergraduate engineer has gained informations, knowledge that related to your discipline, develop structure training modules. So these are not relevant to you. And the next one is to tighten construction control. Any questions before we end our lecture? Ada soalan?
Madam, I want to ask,
Yeah.
when will the test held?
9 December,
Week
right?
9 or 9 December?
Let me check the lesson plan. I
Okay.
think 9 December.
9 December.
See
Okay.
here.
So,
Can you see this one?
yes.
Eh,
Uh,
9 December.
it's 9
Location?
December.
I'm not sure.
Location?
Where it
It's
is.
offline lah, face to face.
I have to confirm with Mr. Badru and the coordinator course. Later on, I will
Okay.
tell you.
So the chapter covered is still the same lah, 1 and 2.
Yes.
Okay, all right, madam, that's all.
Yeah. The thing is that you have to practice doing some sort of short essay. How do you deliberate the info, and how do you elaborate, explain on your case study. Because as I said, if you're trying to do some summary writing, there's some beginning, introductions, body of the content, and then the conclusions. The three things main: introductions, body of the contents, and also the lastly conclusions. So you are given one case in the questions. How do you start answering the questions? So that is important thing, meaning that by having these three main frameworks, you can elaborate according to the question given from the case description, and then how do you identify the cause of the problems? Are you trying to elaborate, explain from the strength criteria aspect, and then the effect of water pressure, for example, and what is the other factors that can give to the cause of the failure, and how do you propose any mitigation work in terms of the design analysis, in terms of the guideline, the standard manual requirement, etc. So these are the when you go on any topics or any chapter in forensic engineering, they will be similar. Dia punya storyline tu yang ubah. Tapi penceritaan dia tu untuk struktur cerita dia lebih kurang sama je. Betul tak? Kita nak tengok punca dia apa, kesan dia apa yang you nak propose. Mitigation work during installation ke, mitigation work during construction ke, apa benda.
Okay, madam.
Boleh?
Thank you. Boleh.
Okay, we end our lecture. We will resume next week. Again, as I said, for replacement class last Monday, so I have replaced using recorded video, but you have to take the attendance for that session, 5th December. So meaning that today you're going to take 2 times, one for 10 a.m. session and another one for 1 p.m. session. Okay, in the near future. Boleh?
Boleh,
Boleh.
madam.
Again, if you do not have any more questions, we end our session today. Assalamualaikum and goodbye.
Bye, madam. Thank you.
Salam, thank you.
Thank you,
Thank you,
madam.
madam.